Here we go, translating problems into equations. So these are the kind of things you're gonna see more often than not. You're gonna see story situations and you're gonna have to dissect how they relate. And you're gonna have to figure out the relationships that different things have with each other. All right? Now, rather than have you just do the examples in the book with me, again, I'm going to keep on kind of trying to give you extra samples. And drawing from my textbook, I have several samples that may work for you. Okay? So this is going to be my example 1. There are, and I'm going to write as quickly and as short as I can, as many people drinking coffee versus tea. The total number is 300 people. We're going to build an equation that would allow us to find out how many of each type there are.
Anthony and Isabella passed Coletti to the office. She'll be leaving for the day.
So if I were to chart it out, and this lesson doesn't necessarily use charts the same way I do, but anyway, if this lesson were to chart it out, it might say how many people drank coffee, how many people drank tea. Well, I don't know much about the tea drinkers versus the coffee drinkers, except for the fact that whatever tea is, tea, literally tea, coffee is double that. So how can I relate to tea and make coffee double?
T plus 2 times T equals 300.
So 2T would relate to coffee. Now, the sum of the coffee drinkers and the tea drinkers is 300 people. Okay? Again, we're not solving it, but we are building an equation that would allow us to do so. Based on the data we've established, an equation of 2T plus T equals 300 is exactly what they're looking for. I bet you could probably tell me how many in each, right? 100 tea drinkers? Yes.
If you were to put it, like, let's say we still take which I
Coffee.
if you were to put it 1/2 coffee and coffee.
Exactly right. So you just hit the nail on the head that sometimes you might not think of doubling coffee. You might think of having coffee and making it tea. And if you get what I'm saying, I can show that to you in greater detail. It's kind of like me saying, how old are you? 15? Okay. So I am 30 years older than you. So I am J plus 30. Actually, J plus 29. He is M minus 29. So depending upon what you name, you can relate then to the other item. Okay? And if I've just flown over your head, don't even worry about it. All right. Example 2 in the textbook has us identifying pieces of things. All right, so one thing is bigger than the other. One thing is smaller than the other. It might look like this. And here's my example. A log, I don't want to write in cursive, 9 feet long. A log 9 feet long gets cut into 2 pieces. One piece is 1 foot longer than the other. Give me the length of each piece. We're not actually going to give it, but we're going to create it so that we can. So I don't have coffee and tea. I have logs. How about small log, big log? small log, and big log. And instead of writing how many, I'm going to give some details, right? And the details are size. Size meaning bigger or smaller. Now, like Justice said, depending upon what we refer to, we can either subtract one from the big one or add one to the small one. So if I am related to small, I'm going to call small small, and I'm going to say big is s plus 1, right? All of this is about relationship with the small. However, if you relate it to the big one, then you could do it this way. And this refers to relationship with the big item. Either way would work, and if you solved it, you would see that. So the sum of these things is what? The total length of 9, right? So that equation is true. And that equation is true. You might think, how is that possible, Mrs. Myers? They absolutely are not possible. Well, when I add 1 and then divide by 2, I would get 5 here and 4 here. However, when I subtract 1 and divide by 2, I would come up with 4 here and 5 here. So based on the relationship the numbers have, I know this one's 1 smaller than the big one, and I know this one's 1 bigger than the small one. So it's all about what you're referring to, right? Old or younger, big or smaller. Okay, things like that. We're going to go through a couple more of these, like we're going to go through the odd items, just a handful of them, okay? And I have you guys going all the way up to number 12 today. So I'm actually going to start at the hardest one, which is number 11, and work my way backwards. And I'm doing that because I want to make sure and get to the hard ones, and I don't want to take up too much of your time, okay? So we're going to go over the problems starting on page 24, and it's odd. Of course you can look up the answers in the back yourself, but that's not going to help you. Okay, looks like we're discussing school supplies, right? School supplies. And it looks like we're discussing Mandy versus Barry. Barry is a name from the 70s. Why do we still use it? Okay, anybody know anybody named Barry other than like your grandpa or Uncle Barry or anything? Barry. What do we know about what they spent? Well, we know that Amanda spent more than Barry, right? So if Barry spent what Barry spent, then what did Amanda spend in relationship to him? Sadie, any ideas? Based on number 11, if Barry spent what Barry spent and Mandy spent $2 more, how would you relate that using B to represent Barry? Nope, that's twice as much. We're adding 2. B plus 2 is right. So that's the first blip there in number 11. And then they said together they spent $34. To me, that sounds like a sum. The sum of those two dudes, people, is $34. So B plus 2 is 34. Once I solve B, again, we're not solving yet, I can add 2 to it for Mandy's amount. Okay, that is 11. Number 9 is the exact same thing, but we're not talking about money. We're talking about sales calls. This is a count of sales calls. Sales calls. Shelley made 5 more sales calls than Clark. So if Clark is C, what's Shelley? Any ideas? C plus 5. What if Shelley's S? What's Clark? S minus 5. Either of these will work, okay? My book and your book, when you look at odds, will probably only give you this answer. But just recognize that if you think of it this way, you're okay as well, and I'd be able to figure that out, so don't worry about it. Okay? The total, sounds like sum, is what? 33 calls? So, C plus 5 is 33. Did you ever believe algebra would be this easy? It really is. It really is. 7. I could do this one. You guys could do this one in your sleep. Yep, I know. Lisa walked 8 kilometers more than Tim. Okay, Lisa, Tim. What are we talking about? Are we talking about sales calls? We're talking about money? Distance, wonderful. Kilometers, wonderful. Whatever you decide to use to represent that. Lisa walked 8 more than Tim. What variable do you guys want to start with, T or L? T. L is fine too. So if Lisa walked more than Tim, she's Tim plus 8, right? Yep. Don't laugh, it'll be you someday. If Lisa walked 8 more than Tim, then Tim is either of these scenarios, because of our starting point, old or younger, either of those scenarios will work. Your book is going to give T, so it's, how far did each walk? Oh no, wait, I'm wrong. Hold on, I didn't finish it. Lisa walked twice as far as Tim. Uh-oh. I got ahead of myself. We don't know anything about Tim. We do know that she walked 8 more than him, but we also know that her distance is double him. Sorry, I went mixing 2 problems. Made a mistake there. I apologize. We don't know anything about Tim, though. But we do know that her distance is this, and it is that. How can I represent that in an equation? Any ideas? Go ahead.
3t plus 8.
Great guess. Super great guess. These 2 things equal one another, right? How can I represent 2 things that equal one another? Like that. She's right. Her distance is 8 more than Tim, which also happens to be double Tim. And how would you solve it? Well, if you subtracted t to the other side, you'd have t equals 8. And that means she's 16. But we're not solving it.
That's the problem. It says underneath it, it says how much money or whatever. My brain just keeps wanting to solve it.
I know. That's 7. One more. And this one's back to the 2 pieces of information. Number 5. I refuse to do 3 and 1 with you. I'm afraid you're going to doze off. Lee biked 3 kilometers farther than Wing. Sounds like distance again. And we know in relationship to each other, Wing is Wing, but Lee is Wing plus 3. Wing is Wing. Lee is Wing plus 3. The sum of their distances is what? Sum means add. 25, thank you. Which means if I take Lee and I add Wing to it, I have 25 kilometers. Okay? There's your details.